of fault, it can sense the fault and it can make the operation. Restoration of the supply can be quick in the case of MCBs because we can turn on it easily, but without rewire the fuse we cannot have the possibility of the restoration of the supply if fuse is used. Handling of the MCBs are easy compared to the fuse. At the same time, only the disadvantage is there. MCBs are much costlier, much costlier than the fuses. ELCB. So the circuit breakage which is connected with to the earth path, it is known as the ELCB, earth leakage circuit breaker. It may happen some currents are not going to the sense by the MCB or the fuses. In that case, the leakage can be done which can sense by the ELCBs. There are two types of the ELCBs: voltage earth leakage circuit breaker, current ELCB is there. How we can identify? So one earth wire is coming into the ELCB from which we can recognize there is the ELCB is there. Simple construction of the ELCB. This is the coil, working coil, where we trip coil is there of the ELCB which can sense that fault is there, given to the trip coil which will operate, this contacts are going to operate, and there is going to be the protection. Typical diagram for the ELCB where wire is coming for the earthing side which sense the fault, or ELCB will work on to that one. Relays are the device which can sense the abnormal condition or the over voltage condition, over current condition. Relays have the one or more magnetic circuits, contacts are there, and the relay operates under the overcurrent condition, under voltage condition. When operating force onto the coil exceeds the restraining force, that relays are going to operate. There are two major type of the relays: attracted armature relay or the induction disc relays are there. Attracted armature relay, let's go quickly into that one. What happened? This particular armature is there, relay coil is there. If overcurrent is there, this particular hinge is there on which this armature is going to sense, or the fault is there, it will come in contact into that one, and there is going to be the trip coil is there. Similarly, this is the balanced beam relays are going to be there, and it will work on to the same principle. Induction disc relay, where the coils are going to move and the trip coil is going to come into the contact when disc is going to move due to the force, and we are going to have the sense of the fault, and the switches are going to, or the circuits are going to operate into that case. Thermal relay, a bimetallic strip is there which will connect into this particular contacts, and what happens, normally closed condition will go with the open circuit condition. The trip contacts are going to be there, and due to the more generation of the heat, that particular bimetallic strips is going to have the expansion, and the trip signal or the tripping command is going to be there, and that particular circuit is going to work. Actual construction of the relay, what we have just talked about, every typical diagram, this armature is there or plunger is there, contacts are shown over here, this coil from which that particular currents are going to flow, body of that particular, a spring plunger is there, a spring mechanism is there which can lead to the opening of the contacts of the this particular things. References, and thanks to everybody.